right, so we've got f of x is the graph. We've got g of x as the integral from 0 to x of f of t dt. And part A just asks us to, now I've closed this. There we go. Part A asks us to find g of -6 and g of 8. So g of -6 and g of 8. If g of x is the integral from 0 to x, then g of -6 ought to be the integral from 0 to -6 of f of t dt, which ought to be the opposite of the integral from -6 to 0 of f of t dt. Just flip the limits. Since this is -6, we don't want to go backwards. We want to go left to right. So we flip the limits and make it negative. And now we'll integrate from -6 to 0. So we have the opposite of. And then from -6 to -5, that's width of 1 or a base of 1 and a height of 2. So that should be 1/2 of 2 times 1. So that's a 1. And then this here, sorry, that's a -1 though. This up here is the same. So that's a +1. And this little triangle, we could do both triangles together, I guess, if we wanted to. But this little triangle here is 2 by 2. So that's 1/2 of 2 times 2. So that's 2. This one is, again, 1/2 of 2 times 2. So another 2. And we should end up with, what does that come out to be? -4. And then for g of 8, we got an integral from 0 to 8 of f of t dt. And to figure that out, we need to find the area underneath the curve from 0 to 8. So the piece from 0 to 4 is the piece that is below the semicircle. So the piece that's below that semicircle is that entire rectangle, which is 2 by 4, 8, minus the area of the semicircle, which is 1/2 of pi times the radius squared. So that takes care of 0 to 4. And then we've got from 4 to 5, which is a height of 2 and a base of 1. So 1/2 of 2 times 1 is 1. And then here we've got all of this. This is a base of 3 and a height of 2. So 1/2 of 2 times 3 is -3, since it's below the x-axis. And then we just simplify. So we got 8 plus 1 is 9, minus 3 is 6. And we got minus 1/2 of 4 pi, so 6 minus 2 pi. Everybody good there with part A?
For g of -6, do you not have to do anything with f of 0? Like you didn't even, where you like subtract 2 from it, like you're to set up the integral where it would be like -6 to 0 of f of t dt would be f of -6 minus f of 0.
Nope.
Like you just solve. Why wouldn't you though? Just because isn't that evaluating an integral at the upper limit and the lower limit?
Sorry, say the second part of that again.
Because don't you have to evaluate the integral at the upper limit and the lower limit? Like you just solve the integral and then set it equaled g of -6, but doesn't that integral equal g of -6 minus g of 0? And so then you have to further solve for g of -6?
No, because I didn't give an initial condition. There was no, so like some of the other ones, I said something like, I don't know. I said something to the effect of like g of 5 is equal to, 3. Find g of 2.
Okay.
Right. So in that case, you had to use this initial condition, say, and make it the integral from 5 to x of, sorry, not of g of t, of f of t dt plus 3 is what g of x equal to. And then you'd plug in the 2, and then you'd use that initial condition, put your integral, and do it that way. But since I didn't give any sort of initial condition, I just said that this integral is equal to the integral from 0 to x. That means that at, erase this important stuff. That means that at 0, this integral is equal to 0 because g of x, g of 0 is the integral from 0 to 0 of f, which is.
Okay. Could you just do it that way too if you really wanted? Like instead of just ignoring it, could you just plugged in 0 and gone the integral from 0 to 0 is just 0? Could you, or does that work? Right?
You could, but then you still have to do all of this work. I mean, then you just end up with a 0 plus at the beginning of each of these.
Okay.
So.
But you can just ignore it for the most part if no initial conditions given.
Correct.
Okay.
And then somebody was asking where I got the 8 before the 1/2 of the pi times the 2 squared. That's the area underneath this is this right here. And so I took the entire rectangle and knocked off the semicircle. So the -4 or the -1/2 of pi times 2 squared is the semicircle part, but the 8 is the area of this entire green rectangle. No problem. All right, part B. What did part B ask us here? Does it have any points of inflection? Okay, so G has points of inflection if its second derivative changes signs. So that's what we're looking for. G double prime is equal to F prime. So we're looking for when does F prime change sign. So when does the slope of F prime go from positive to negative or negative to positive? Well, right here at -4. Again here at -2. Again here at 0. Again here at 2. Again at 4. And again at 6. Got 6 different points of inflection, right? F prime goes from positive to negative. Right? The slopes go from positive to negative, then they go from negative to positive, then they go from positive to negative, then they go from negative to positive, positive to negative, negative to positive. So 6 points of inflection for G at these 6 values. Everybody good there?
Yeah.
Okay. Part C asks for local maxima and minima. So that means when G prime is equal to 0, and it said the open interval, so we don't have to worry about endpoints. If G prime is 0, that's when F is equal to 0. Since G prime is F, so when does F equal 0? Well, F equals 0 at a bunch of places, here, 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 and here, but it has to change signs also here, but that's not included on our interval. So it has to change signs, but it doesn't change signs at 2, and it doesn't change signs at, -2 or at 2. It changes signs at -5 from negative to positive, which means that if the derivative is going from negative to positive, it means the function is going from decreasing to increasing. So we have a local min at -5. And we went from positive to negative, which means the function goes from increasing to decreasing at 5, which tells us we have a local max at x equals 5.
If it was a closed interval, would you have a local max at -6 and a local min at 8?
If you were on a closed interval, let's see here, you would have this is still negative, so function would still be decreasing. This would be a local min at 8. And then this one's going backwards. So because G is equal to the integral from 0 to x, this one, as I go backwards, I'm taking the opposite of my integral as I go from -6 to 0, but I'm adding in these positive values, but it's the opposite of those. So these are all actually negatives, and this is like adding to that. So we'd have a local max there at -6. Does that make sense?
Yeah, if you just did a sign chart, would that be like good enough to show that -6 is a max and 8 is a?
That would do it. Yeah, somebody asked me to repeat my reasoning for the local max and the min. So this is when F changes signs, right? So the derivative of G needs to change signs, and the derivative of G is F, and so F changes signs. It goes from negative to positive here, and it goes from positive to negative here. And if F goes from negative to positive, G goes from decreasing to increasing. And if F goes from positive to negative, G goes from increasing to decreasing. Everybody good there now? Okay. All right, and then the last part of this one, part D, asked for the absolute max, I think. Is that right? Absolute max or absolute min?
Max.
Absolute max, okay. So we know that there are only a couple places where this could occur. One is where we had a local max, which was at 5. So we're going to need to find g of 5. And then the other was at g of -6, right? Because that was another place where we were saying there could have been a local max, and now we have a closed interval. Technically, we should check, we should always check the endpoints on a closed interval. This one we don't need to check, because if we're maybe at a max here at 5, all we're adding in is negative values to g as we go from 5 to 8. So this endpoint, as we said, is a local min. So we don't need to bother to check that. So we need to find g of 5 and compare it to our value at g of 6. So g of -6. So we know g of -6 was what, -4? And then we'll find g of 5. So g of 5 is the integral from 0 to 5 of f of t dt. And we already had that first part, it was 8 minus 2 pi from 0 to 4. And then we have to add in 1 unit here from this little triangle, like we added in 1 unit from it before. So that's 9 minus 2 pi. 9 minus 2 pi is clearly more than -4. So our absolute max is 9 minus 2 pi at x equals 5. Any questions on part D?
Sorry, can you quick re-explain why we have to consider the point at -6 again?
Say that again, I couldn't hear you.
Can you explain again, like, why we had to check the value at -6?
Yeah, we need to check at -6 because first off, it says it's a closed interval now for part D. And so this, if we think about a sign chart for our derivative, this is like, remember that f is our derivative. So if we look at the sign chart, the derivative is negative, which means g is decreasing, and then g is increasing later. So right, g starts out decreasing, which means that the endpoint at -6 is a local.
Oh, I see.
So it could be that this value at that local max is higher than this value at this local max. So we actually got to test them. And if we had other local maxes, you'd have to test them all.
Okay, thank you.
Yeah, so somebody's asking, wouldn't I know that it's not the absolute max? So I'm not actually adding more stuff in here. I'm actually taking away stuff. So we got to think about this way. G of x is the integral from 0 to 6. So I'm losing value here, but then I'm regaining that value as I come back. But really, so it's sort of hard to explain it in words. I don't know, the best way to think about it, I guess, is let's see here. What's the best way I can explain this? I mean, yeah, I guess technically, yes, we're adding in this area. So we know that we're most likely going to be up higher. And since there was nothing else below, so Lindsay, I mean, since there's nothing else below down here in between, you would probably be able to, I mean, you could just eyeball it and say, clearly, I'm adding in so much more here than I was subtracting here as I went to the left. That it wouldn't be, but on the AP test, they'd want you to show that this value is less than the value of 5. So I'm going to want you to do that on the quiz as well. And then somebody's asking if I can re-explain why 8 is a local min and -6 is a local max. So -6 is a local max because we know that G prime is f of x, right? And G prime, the sign of G prime tells me what G is doing. So the sign of f tells me what G is doing. So the sign of f is negative here, which tells me that G is decreasing. So if G is decreasing, then that means at the left endpoint there, we have a local max. So that's why we have to test that to be an absolute max. And the same over here at positive 8. Right, I know that my derivative, f, was negative, so at the end I'm decreasing, and so that my endpoint that I get to down here is a local min. And that, to answer somebody else's question, that's why I don't bother to test 8 to see if it's an absolute max, because we know that it's a local min. So if it's a local min, it's definitely not an absolute max. And the same with negative 5. Negative 5, since we were going down and then increasing, this is a local min, and it only asks for absolute max, so we're not going to have an absolute max at a local min. Does that make sense to everybody? Cool. Yeah. All right, any other last second questions on this before we get started? Yeah. Nope. Back to the page with C and D. There it is. Everybody good there now?